When we talk about wind, we are talking about the general motion of air. Now, there are three different ways that wind can actually move. We can either have upward movement over a region of hotter air, due to greater heating. We can have the opposite, which would be sinking air over a cooler region, or you could have horizontal wind moving between warmer and cooler regions. This is the horizontal wind, the horizontal movement of air that we generally feel here at the surface of the Earth. Now, to understand the local wind patterns, we need to understand two very important relationships. One is the relationship between temperature and density. That the relationship between temperature and density is that when you increase the temperature, you decrease the density. So they are inversely proportional. Increase one, decrease the other. So since higher temperatures have lower densities, it causes that air to rise. So hot air rises. But if you decrease the temperature, you increase the density, makes it more dense, and so it will sink. So cold air sinks. The other important relationship is the relationship between air pressure and air movement. Now, when you have a region that is warmer, such as we have on the right side of this figure, we already saw that that air is going to rise. Well, upward movement basically removes air from a certain region, therefore decreasing the pressure. We end up having a lower pressure beneath that rising air. On the left side, when you have the cool surface, you're going to have sinking motion. The opposite happens. The sinking motion is going to cause a region of high pressure. The other important relationship between pressure and air movement is that generally air moves from high to low. As a result, we end up with a complete cycle. That cycle will determine local wind patterns. Here are some examples of some local wind patterns. One example we experience all the time here in Florida, it is the sea breeze. The land will warm up much faster than the water does, and so since the land is warmer, air is going to rise over land, sink over water, creating a cycle that will push air from water onto land. This is known as the sea breeze. This will last as long as the land is heating up faster than the water. And the greater the heating, the stronger the sea breeze is, which is why sea breezes are most common in the summertime. At nighttime, you have the opposite. The land will actually cool faster than the water will, so the land becomes colder, reverses the cycle. This is known as a land breeze. Another good example is mountain winds. You have some heating on a mountain side and in a valley, and since that air is going to be heated up, hot air rises, and so it will go up the slope. Now, global wind patterns are far more complicated. It is very hard to exactly describe all of the global wind patterns. However, we can get some good generalizations. Here's a good summary. The equatorial regions of the Earth are going to receive more direct sunlight. As such, the hotter latitudes are going to be near the equator. And since it's hotter, that's where we're going to have rising air. At the poles, you're going to have more indirect sunlight. And since it's more indirect, it's going to be colder. That's where we're generally going to have our sinking air. So in general, you have rising motion over the equator and sinking motion over the poles. And thus we complete our cycle as I just drew here. However, since that's such a large distance, that cycle is generally broken into 3 cycles, because we do have a tendency for air to start sinking around 30 degrees latitude, creating a region of high pressures. And then we also have some more rising motion around 60 degrees latitude, creating a low pressure. This low pressure around 60 degrees is around the region where a lot of winter storms form. One thing that's important about weather is that severe weather, rainstorms, typically are associated with low pressure systems. Clear skies are more associated with high pressures. Speaking of that, since clear skies are associated with with high pressures, I want you to just take a second and look and see where all of the deserts in the world are. You would find that they are primarily right around 30 degrees latitude. The last point here regarding wind has to do with the jet stream. The jet stream are loops of wind, high currents of wind that loop around the Earth near the top of the troposphere. These currents of wind have speeds of 100 miles an hour or more. That is what a jet stream is. The most dominant jet stream that we deal with, let me do this in blue. The most dominant jet stream we deal with is at around 60 degrees latitude and just goes around the globe. However, it's not a constant curve at 60 degrees latitude. It actually kind of wobbles up and down, moves around a little bit more, centered generally around 60 degrees latitude. And when it dips down, it usually brings storms into the United States region. Another very common jet stream that we are more associated with here in Florida is another similar jet stream called the subtropical jet stream, which happens right around 30 degrees latitude. This subtropical jet stream has a lot to do with the type of weather we have, whether it's going to be a hot and dry summer or a very rainy summer. It can also strongly affect the intensity and frequency of hurricanes.